Hey everybody. So we're going to solve this three variable system of equations using just elimination. And so if that's my strategy here, what I'm actually going to look for is see if there's any of the variables here that were like, I can use one of the particular equations, like one of the variables in one of the equations, as kind of the eliminator to go after the other equations. And so in this case, I'm looking at this y right here. It has a coefficient of 1, so it's going to be really easy to multiply this equation by whatever number so that I can cancel it out with the y's in the other equations. So the first step here is I'm going to multiply this equation by 2, and then I'm going to get 12x minus 2y plus 8z equals negative 2. Don't forget to multiply the constant on the other side. And then I'm going to combine that with equation 1 here. So I'm going to have 4x plus 2y plus 3z, just copying it over, equals 1. And so now I'm going to add these two equations together. I'm going to get 16x, the y's cancel, plus 11z equals negative 1. So this is my first new equation here. And then I'm going to go back to this same equation. I'm going to use this same variable, and I'm going to eliminate the y in the other equation, in the second equation of the 3. So in this case, now I'm going to multiply by, instead of 2, I'm going to multiply by a negative 3. Because what I want this to be is become a positive 3y. So when I do that, I get negative 18x plus 3y minus 12z plus 3. And then I'm just going to bring down this equation here. I'm going to have 2x minus 3y plus 5z equals negative 14. And then I'm going to combine these, again with the goal of eliminating the y's. So now I'm going to get a negative 16x. Here I'm going to get a minus 7z, and there I'm going to get that equal to negative 11. So this is my second new equation. And again, the goal here is to go from 3 variables and 3 equations down to just 2 variables and 2 equations. Because we supposedly know how to solve those. That's what we were doing in the previous week. Notice the 2 variables here are the same 2 variables, x and z and x and z. If we had x and z and x and y or something like that, then we couldn't combine these. That wouldn't work. So I'm just going to rewrite this really quickly. I'm just going to bring this down. 16x plus 11z equals a negative 1. And I'm going to write this over here. Negative 16x minus 7z equals a negative 11. Now it's really convenient in this example that we don't even have to do anything, and the x's are going to cancel out here if I do some more elimination. So usually we would have to like multiply one of the equations or both the equations by something. But in this case, this is a one-stepper. It's already set up for me. So I'm going to add those are going to cancel out, and I'm going to get 4z equals negative 12. Divide by 4. So 4z equals negative 3. Oh, but that's just the first part of our solution, right? So there's still more work to do. I need to take this z equals negative 3. I need to plug it back into somewhere so I can solve for one of the other variables, either x or y. Well, if we go back and look at it, plugging z into one of these equations over here isn't really going to help us because we're still going to have 2 variables, like an x and a y left over. So actually I want to take this z and I want to plug it back into one of these 2 equations where there's only 2 variables left. So let's put it into this one. Doesn't really matter. It should work either way. But I'm going to plug it into this one here. So I have 16x plus 11 times negative 3 equal to negative 1. So that's 16x minus 33 equals negative 1. I'm going to add 33 to both sides. I get 16x equals 32. Divide both sides by 16, and you get x equals 2. Okay, so now I have 2 variables. I have the z equaling the negative 3, the x equals 2. Now I need to go back and solve for y. So going back to one of these 2 equations isn't really going to help because they don't have a y to solve for. So that means now I need to go back to one of those 3 original ones that have all 3 variables in it. So it doesn't really matter. I can choose whichever one I want. So let's go with the first one there. So I'm going to have 4 times the x was 2. And then I have plus 2y. I don't know what y is still. Plus 3z, and z is negative 3. And that equals 1. So now it's just combining like terms and simplifying. So I get 8 plus 2y minus 9 equals 1. That gives me 2y minus 1 equals 1. Add 1 to both sides. 2y equals 2. Divide by 2. You get y equals 1. So there you go. So I have all my 3 variables. But like a good mathematician, I'm going to write my solution as an ordered triple. I'm going to put a box around it. And there we go. Now, if we wanted to graph it, what we would do is set up our axes. Again, this is the x-axis, this is the y-axis, and this is the z-axis. I'm going to go 2 down the x-axis. I'm going to go 1 over on the y-axis. So if I make my parallelogram or rectangle, it's going to be right about there. And then I need to go down 3. So from this corner of the table, I'm going to drop down 3. I'm just eyeballing it. Let's say it's that far. And again, I'm going to go down 3 here, down 3 here, down 3 from the back side there. Fill in the rest of my box. And my point there is 2, 1, negative 3.